Nice to it's so nice to be back. I hope you guys all had a good break, a relaxing break. Today we have Alignable, and they're going to talk to us about complexity management. We have Pascal, who's the CTO, and he's graciously given us our time to give us a really cool presentation. So yeah, hope you guys like it, and I'll let Pascal take it away.
All right, awesome. Let me share my screen. And I just had the window. There it is. All right. So this was not the talk that you guys were supposed to hear. It was supposed to be by another engineer, but he, I would say unfortunately, but that would not be fair. His family just welcomed their first child in, so he's taking some time off. So we decided not to drag him out and have him present. But because of that, I'm going to give a slightly different presentation. We're going to call it the craft of coding. It's actually a sort of a slight modification of a talk I give to sort of new co-ops that come on and new engineers that come on. I changed the name from complexity management engineering because of the look of concern that Anu had on her face when I suggested that was going to be the name of the talk. So we've changed it a little bit. I promise you it's not going to be overly painful. We'll try to keep the pain scale sort of right there in the middle. So my background, I'm the CTO at Alignable. I've been here for about 8 years. I graduated EECS from MIT in 2002. I love coding. I've been doing it for a very long time. We'll get more into that in a second. I also love gardening. My family went full pandemic homestead, this year. So we've got the ducks and the chickens and all that. So the bees are coming in the spring. So, I come from a sort of a long line of builders and tinkerers, as I like to say. My grandfather was, an inventor. He held a few patents on, different types of compost, composts and, various kitchen instruments. My father is a civil engineer who was sort of always tinkering around with something. My brother and I kind of caught that bug. And, even at an early age, I always had access to kind of the workbench and tools. And sort of when I think back and I think about craft, kind of the picture is always that sort of dusty basement, workbench that I would, go down and build, horribly, disfigured birdhouses in. Sort of at an early age. And then, in 1986, my family bought a Franklin Ace 500. You may not be familiar with this particular model. It is a Apple II knockoff that was pretty much sued out of existence, within a year or two. And I still remember this quite vividly, and it's definitely sort of a fake planted memory that I've recreated in my adulthood. But like I remember this, this game I was playing on the Apple II crashing, and it sort of, crashed out to like a basic prompt because some of the games were just written in basic, and so that piqued my interest. We're talking about a very different world. The instruction manual that came with that computer actually had the full syntax of the basic programming language in it and every command you could run. So like I started screwing around with it. And that kind of changed my life in the sense that I started just playing around, building random programs on, this Apple II knockoff. And I sort of have always just seen kind of coding as, tinkering, at sort of at a different speed, right? You can build things, you can build them a lot faster if you don't really have to screw or glue them together or, hop down to Home Depot to buy something. So, that started sort of my lifelong love of coding. I've been doing it for a very long time, as I said, and, I still try to do it, every day I'll be doing it. They've kind of tried at Alignable to like pry my keyboard out of my hand. They're like, you're the CTO now, you have, more important things to do, but, so far they have not been successful. And kind of one of the things I've noticed over the past 35 years of coding is that sort of as little projects and stuff you work on grow, they always seem to cross this threshold, which I've given the technical term of the fun, not fun threshold. And, you know, sort of all projects, they kind of start out as fun, and at some point you just realize you really don't want to work on them anymore. Even if you really, you know, want to sort of finish them, it's tough to drag yourself back to them. You know, originally I just thought, oh, you know, I'm actually just always attracted to kind of the shiny new project, but it actually goes a little bit deeper than that. And in the back of my mind, it's kind of always bothered me, and I've always been sort of thinking about, well, why, you know, why do these things get unfun? You know, I love coding, but why do I kind of always move on? And interestingly enough, different projects and different languages and frameworks, which would sort of shift that tipping point, right? Like, depending on, you know, personally, if I build a project in Java, I want to run as far away from that thing as possible, you know, the next day. But, you know, languages like Python and Ruby, you know, I'd sort of hang on for a little bit longer. You know, and then, you know, it kind of just became one of these sort of enduring mysteries, you know, sort of like why some people prefer Emacs over Vim, or why some people don't like Hawaiian pizza, that I just will never really understand. So, you know, keep this in kind of the back of your mind. We're going to shift 120 degrees and talk about performance. So, so how do you become better at programming? Or generally, how do you become good at just about anything? You may or may not be surprised to know that there's actually a whole field that is sort of dedicated to the study of performance. And this guy, Anders Ericsson, wrote this really fabulous book called Peak that I highly recommend. He's sort of the, you know, I would say he's sort of the foremost authority on this. And if you sort of read some sort of quote or, you know, study about expertise, it somehow will probably always link back to, you know, the research that he's done. And sort of the quote from the book that I think defines it most succinctly is basically, no matter what field, the most effective approaches to improving performance all follow a single set of general principles. We name this universal approach deliberate practice. Today, deliberate practice remains the gold standard for anyone in any field who wishes to take advantage of the gift of adaptability in order to build new skills and abilities. And he's, you know, you may have heard of the 10,000 hour rule. You know, he's sort of the inspiration of that. He actually wrote this book, Peak, because he thinks people completely misinterpret his work and what he said. So obviously the next question is, okay, then what the hell is deliberate practice? Well, deliberate practice involves feedback and modification of efforts in response to that feedback. Early in the training process, much of the feedback will come from the teacher or coach, who will monitor progress, point out problems, and offer ways to address those problems. With time and experience, students must learn to monitor themselves, spot mistakes, and adjust accordingly. Such self-monitoring requires effective mental representations. So I would sort of posit then that software engineering has a problem, right? We don't actually have, we've got a lot of classes and a lot of things that sort of teach us, you know, teach us how to build things and how to, and certain techniques, but we don't really have sort of general agreement on what good code looks like. You know, generally there's not kind of a coach-based feedback loop, you know, except maybe very early on in your, you know, engineering process, where people are kind of looking actually at your code and really deeply looking at, you know, is your code good? Stuff may have changed, you know, in the intervening years since I was in college, but a lot of what sort of computer science classes I took are what I would call outcome based, right? Does your code run and does it do the thing it was asked to do? Versus, you know, did you decide on, you know, and does it do it fast enough, right? Like, is the outcome of the code, you know, right? Or, you know, and if your only feedback loop is like your compiler, or, you know, the fact that it doesn't crash the minute you open it up in a browser, you know, that's not the right feedback loop. And I would say sort of in the real world, a lot of times the code is the primary product, right? That's what's going to endure. That's what someone else, another engineer, is going to have to pick up. That's what someone is going to, you know, crack open, you know, 6 months later and, and try to understand what the person writing that code was thinking. They sort of say like code is written one time, is read 10 times more than it's written, right? You're gonna spend 10 times more trying to read and decipher code than the time you spend writing it. And we don't really have a really good metric, a really good sort of practice of kind of evaluating code. Code reviews obviously help, but unless there's sort of consistency in the qualitative feedback you get from those code reviews, I've seen them a lot of times just sort of devolve into syntax argument. Where do you put your curly braces? Should I use tabs or spaces? And interestingly enough, without that feedback loop and without sort of a way to constantly improve, you're not going to be doing deliberate practice, right? And just practice without kind of the other part of it leads to a lot of times sort of this leveling off or this decline. And if you don't believe me, I have a quick question. Your parents have been driving for much longer than you have been driving. Have they just been have they become better and better drivers as they've gotten older and they've done more driving? I would say chances are, you'd agree with me that there's sort of there's sort of a plateau you hit, and then you sort of stop paying attention, right? Like your actual kind of top level of performance doesn't continue to increase. Obviously, some people become very good at driving, right? They become F1 racers, and their performance continues to increase, but that takes training and practice. And we sort of don't have the backup, we don't have the general agreement in the engineering world for doing that. So, I mean, my question is, what makes good code? And as I sort of alluded to earlier, it's not just that it works, right? Like that's the outcome. That's almost the baseline that you expect. And well, does good code matter? I would say, speaking from experience, it matters very much. It almost matters more than anything else, right? The quality of your code base at a company is going to determine how fast you can move as a company, and how quickly you can build and change, and continue to provide more and more value to your users. The part of a lot of times sort of the value is deferred, right? It doesn't, if person A and person B both write code, and on the outcome, outcome evaluation, the code does the exact same thing. It's not going to come until 6 months later when you try to change that code or you try to extend it, that you're really going to realize, is this good code? Is this bad code? What in God's name is going on here, right? And that's part of the problem. So, a lot of times it kind of comes down, unless there's a strong culture around, mentorship and really deep, code reviews. It's really tough to improve if you're just sort of sitting in your own little coding bubble. And so, like, why it's sort of weird. Why is that? Why is the question of what makes code good a hard question? And we're going to kind of leave that hanging, and let's spin a little bit, another 128 degrees to the human brain. So human brains are limited. And originally there was sort of this idea that there was this old study by this guy called George Miller from 1956 that pointed to sort of this magic number of 7 plus or minus 2, right? So you could hold 7 things in your brain in kind of short-term working memory. Some people could do 9, other people could only do 5. Later research put it somewhere around 4 chunks in young adults. But the basic idea is we've got sort of this limited amount of working memory, and this little amount that we can stuff into our brains as we're trying to work on things. Obviously, tools like autocomplete and syntax highlighting help keep us focused. But a lot of times, we're still really pushing, when we're coding, we're really pushing our brain kind of to its max capacity. But that's not necessarily a bad thing. So, people have probably all heard the idea of flow, right? This flow state when you're sort of, your head down, you know, and really focused. You know, Mihal Csikszentmihalyi, I don't love saying that name, who sort of defined the term, says the best moments in our lives are not passive, receptive, relaxing times. The best moments usually occur if a person's body or mind is stretched to its limits in a voluntary effort to accomplish something difficult and worthwhile, right? And so, you know, if you look at the scales of this sort of pseudo graph we have in the bottom right, at the top right, sort of we're pushed to the extent of our abilities, and we're pushed to the extent of, you know, the challenge that we're facing. But that's when we're happy. That's when we're in a flow state. If we're, you know, if we're sitting and we're plugging in numbers, you know, into a spreadsheet for 6 hours on end, that doesn't put us in a flow state. You know, we're not sort of challenging ourselves. So that goes back, you know, why do I enjoy coding? I think it goes to sort of the two things we talked about. One is I love it from a craft perspective. Basically, you get to sort of design and build things with your mind, kind of untethered from the limits of traditional crafts, right? Part of the problem with software is that there's no upper limit to how complicated or big you can build a system, right? You know, if they want to build a building in downtown Boston, like that, they can only build it so tall, and they can only, you know, import so much concrete. We don't really have that limit as a software engineer, right? We can go as crazy as we sort of have time and, you know, enthusiasm to do. But the other part is that, you know, the act of sort of coding is this creative endeavor, you know, and it's I've sort of thought about, well, why is it always going to be a creative endeavor? You know, they've tried to build these rapid application design tools where you just drag a few things around. But the interesting thing is, like, software engineers always just sort of sit at the very top of the, you know, at the top of the abstraction scale, right? As soon as something is easy, someone just packages it up into a nice library and uploads it to GitHub, and now we get to sit on top of that package. You know, so it sort of doesn't matter where we go. We're always going to have this kind of creative flexibility sitting on top of that, you know, on top of the things that we want to build. And the other part is kind of the flow state. You know, you get to, you know, you get to basically sit in a focused state, and you know, the legendary stories of people just sort of hacking out and building things overnight. You know, those all kind of come from this idea of the flow state and this idea of, you know, you know, sleeping under your desk because you're so kind of into your work. All right, so sort of circling back, because I want to get to the actual point. So starting new coding projects is fun, but, you know, eventually they kind of become unfun as they grow. Deliberate practice is kind of the key to peak performance, but software engineering is kind of missing this baseline qualitative metric for feedback. And lastly, you know, the human brains are kind of amazing but limited, and we're kind of happiest and most productive when we're in this sweet spot of kind of high challenge, high ability. But once we kind of get overburdened and dragged down, you know, suddenly things kind of, you know, start to turn. So kind of the one thing that anchors all that together is this idea of complexity, right? You know, or simplicity, if you want to look at it, you know, on the other side. So let me kind of posit what I call the complexity thesis, which is basically that, you know, software and coding become difficult when the complexity of the project outstrips our ability to understand the systems we are working with. We can mitigate this with a ruthless focus on complexity as our qualitative measure of software quality, and use self-contained abstractions to aid mental representations. You know, so let's unpack that a little bit. But, you know, the idea is that if we can sort of contain the complexity, and one thing that, you know, is very apparent is that without really thinking about complexity, software is always additive complexity, right? When you add something into the system, if you're not trying to mitigate that, you've just added more complexity into the system. And so, you know, as software projects grow and as you work on a project, it's going to grow. That's sort of how it works. You're always going to end up making this more complex system. unless you're really, really kind of focused and concerned on that. So don't mistake simple for easy. Making something simple does not mean that it's easy. I would go as far to I would agree with my namesake, who basically says I would have written a shorter letter, but I didn't have the time. Like, making something short, succinct, understandable, and simple is actually a huge challenge. I don't know if if the Mythical Man Month is still read in engineering curriculums, but to sort of paraphrase it, right? Software is easy, systems are hard. And this kind of gets back to the fun, unfun, issue. Like, if I want to write a quick sort of, command line tool that does some simple thing, I can fire up my IDE, I can write it, and I'll be done with it. And I can sort of wrap my whole brain around the system. I don't really need to think of all these different moving parts. But once you get into systems, systems have these complex emergent features that show up by design, but they also show up sort of accidentally. And part of the reason of that is sort of this idea of complexity sitting on the edges, right? And as the components in a system increase and we get more edges, we have sort of this big O n squared relationship. So as we increase, as we go from K6 to K7, we're not just adding a couple, we're adding a large number of new edges if we're not sort of careful about our interconnections. And those interconnections, right? And the sort of the base thesis of the Mythical Man Month is that the surest way to make a late software project later is by adding more people onto the project, right? You just dramatically increase the number of connections, and you're going to be dealing with a lot more complexity as those people try to communicate, across all those lines. Another great example is, people love the idea of microservice architectures in principle because they're this great kind of way to pull out a component of a piece of software. But people ignore the fact that connections that happen over a network are a lot more painful than connections that happen inside one piece of software. And so, when I see microservice re-architectures on people's resume that we're interviewing, I always ask them about it, and it's I don't think I've once heard the script of the story is always the same. We did it because things were getting complex and out of hand, and then when we ended up doing it, it got even worse. So to look at how do we fight complexity, basically we kind of have we have two options. We reduce n, we reduce the overall size of the system, or we reduce the connectivity of the graph, right? If you are, as you're writing code, thinking about the abstractions and thinking about these sort of self-contained black boxes that you're building, you can dramatically reduce the complexity of the system that you're building. Time allowing, we'll sort of talk about some specific ways. But one of the things that to think about, right? So for floating point operations, CPUs basically they take 1 to 3 CPU cycles to do addition, 1 to 7 CPU cycles for multiplication, and somewhere between 17 and 69 cycles to do a division. So if you think about it, imagine every time you wanted to do division on a computer, you had to think about every one of those 17 to 69 steps that you were going through in order just to divide two numbers, right? You wouldn't be able to do that. We need abstractions, and we need to sort of contain this complexity down into something that we can understand, and sort of put in a box on the side and not have to think about it. So to kind of sum up, you should sort of see your job not as a software developer. You should sort of see it as a what I call a complexity management engineer. So you should always sort of be keeping an eye on what how is the system working, what is it getting out of control, and basically kind of try to ruthlessly manage the complexity in your system. Insert useless grapes analogy here. Right, so back to the gardening thing. We've had wine grapes, which we've grown for a bunch of years, and last year was the first year that we were supposed to really get sort of a full harvest and be able to actually, go make some wine. Of course, they got completely destroyed by, by some pest. So this year I sort of said, all right, I'm not going to let that happen. And so I probably did about 20 different things. I pruned them at the right time. I, sprayed them with the right, organic fungicides. I released a whole bunch of ladybugs on them. We kept them out. We did probably about 20 different things. And this year we had a wonderful, great harvest. I have no idea which of those things, was the important, was kind of the tipping point. But that's kind of how it goes with software, right? You've got to do everything you can to kind of manage the complexity and the of the systems that you're working with, and then you'll notice that you're kind of just happy with the software system that you're working on, right? At the end of the day, it's not any individual thing that you do. It's sort of this continuous application of these principles. What I like to sort of call the craft of coding feedback loop. One thing I would very much recommend is that you write code and you do it often, and you don't just do it in class, right? Figure out little itches you can scratch. That even if there might be some open source library out there already, figure out how to sort of write code that can sort of help yourself on a regular basis. As I said earlier, kind of the 10,000 hour rule was kind of misunderstood because it was assumed to be necessary and sufficient. The idea, the thing is, it's probably necessary, but it's in no way sufficient. So you've got to do step one, but that's kind of not the only thing you got to do. Step two is kind of circle back to your old code and try to understand it. If you've been coding for a little bit, I think the comic on the right will be applicable. I don't think anyone hates your code more than you do 6 months later, right? As you sort of look at that and you're like, I can't believe I wrote it. Why would I possibly have done that? Always circle back and sort of look at what you did, look at what you wrote, and kind of understand why it's not clear, why it used that many lines of code to do something that should have taken 1/10 of the amount, and sort of be ruthless with yourself. The other part is that a lot of times people aren't reading code, right? If you're not looking at other people's code, you're not seeing how other people are doing stuff, right? And that doesn't just mean don't read your other team members' code. If you're doing a group project, read open source code. If there's a problem with a open source tool you use, even if you don't think you're going to be successful, download it from GitHub, run it, take a look at it, see how it does. Look at code from frameworks that you use. Feel comfortable sort of jumping in and reading code, and the more you do it, the more comfortable you'll be with it. And I would say rinse and repeat, right? You've got to kind of, if you really want to get better, you're gonna have to sort of look at the code that you're writing. You're gonna have to evaluate, and you're gonna have to sort of create that feedback loop. I think one of the things I used to always hold it against myself that I would abandon projects, but I think actually sometimes you don't have to finish a project if your goal is just to learn some framework or learn some new tool, right? Feel free to just build something just for the sake of learning it, and then you don't have to feel guilty about throwing it away. Again, like, it can't just be the it works as your feedback loop. I mean, ideally, find peers and mentors to sort of review your code in a positive environment. If you're at a co-op and there is not sort of a strong culture around that, feel free to reach out to your managers and sort of ask if people would be willing to take a look at your code. I'm sure most of them will be. And this is the point where the Alignable VP of Engineering would be mad at me if I didn't mention that we do have a strong positive PR review and dev design and one-on-one development culture at Alignable. So I'll just throw that out there. And again, a lot of times the best code is no code, right? If you can find a way to solve it with a library, or you can find a way to solve it, that doesn't require 1,000 lines of code, that's almost the simplest option. So we're actually doing okay on time. So I think we'll go into some of these nitty-gritty details. I should have mentioned this at the beginning, but if there's any questions, feel free to jump in and ask them at any time, or if something's not clear.
Yeah, and if you don't want to raise your hand and say your question out loud, you can always pop it in the chat. You can even send it to Emma or me or Pascal, and that's totally a fine way of asking questions as well.
Yep, absolutely. Feel perfectly fine jumping in and interrupting at any point in time, especially if I'm saying something utterly wrong. So I created these appendices because I didn't sort of know if we'd make it all the way to here, but let's jump into some of these kind of nitty-gritty details. So again, I kind of consider level 0 like the base level, like it works according to what you want it to do. Give yourself a small pat on the back, but then go and do the actual work, right? Most of the time, if I'm going to, if I've written something and it works, I'm probably like a third of the way done, and I'll probably end up completely refactoring it so that it's sane. Because the first things that I promise you jump out of my keyboard are not always sane. We're just trying to prove that they actually are going to work. And there is a level below 0, which I call anti-patterns. So there are. I have met an engineer who's able to write PHP in absolutely every language, and is some of the most horrible thing that you've ever seen. So when you're writing in a language, there's kind of two aspects. Obviously, there's the syntax, right? It's not gonna, the interpreter or the compiler isn't gonna be happy with it if you've got, if the syntax isn't right. But languages also have a philosophy around them, right? And so take the time as you're learning a language to understand the philosophy around them, understand the standard library and everything that comes along with that language. Read some code, read some examples, read some guides, so that your JavaScript doesn't look like your Python, doesn't look like your Ruby, and definitely doesn't look like your C++, and doesn't look like your Java. The other thing that generally is we don't like to see is to sort of see code whose goal is to be clever, right? Like the goal of code should be to be as close to instantly understandable as possible. There's this very small subset of situations where you have to optimize something to make it run fast enough. So sort of being clever and saving a couple a couple of lines, that is great for sort of a coding competition. But that's probably not what you want to use in the real world. In addition, using sort of novel patterns, or maybe you just read sort of the Gang of 4 book and you're starting to apply design patterns. Just be careful sort of applying them everywhere. It's sort of that if the only tool you have is a hammer, then everything looks like a nail, right? So if you just read the pattern on the on the adapter pattern, don't turn everything into that. Don't turn everything into the dispatch pattern or the factory pattern. Think about the code base that you're working in. And this is not really a coding practice. It's more just sort of a testing practice. If you find yourself saying, "Oh, but it works on my machine," something went horribly wrong. Right? If you sent something to someone or you deployed something, so think about it when you're testing it. When you're testing it, and sort of make sure it kind of works in the real world. And these kind of anti-patterns are kind of the answer to the trivia question. How can someone close tickets and ship code and yet still bring negative value? You can put so much pain and suffering into the code base if you're sort of not thinking simply that, you know, at the end of the day, even if you're sort of shipping code, you know, people are just going to look at git blame and they're going to shake their head in dismay, you know, 6 months from now. So that's kind of level 0 and level 1, or sorry, like level -1. So kind of level 1 is when you're sort of comfortable writing, you know, writing code on the project that you're on, that you're willing to sort of take a step back and look at it, you know, from a meta perspective, and sort of look at the code as an artifact, as opposed to just, oh, does it work, right? So, you know, and you can sometimes, if you're just writing something for yourself, you can sometimes skip this step, but like taking a step back and understanding, you know, the code, you know, as the code is kind of the feedback loop that's going to make you a better coder in the long run. So, you know, so the first thing is that it's understandable, right? You know, if you can, you know, make someone else take a look at it, you know, that's almost most the value of pull requests, is forcing someone else to look at it, or even forcing yourself to look at it as someone else will, and making sure people can understand what the heck it's doing, right? You know, functions and variable names are super important because they tell you what's happening. You know, control flow, does it make sense? Is it jumbled? Is it all over the place? You know, I think people you know, underestimate how important naming is in software development. It's almost like the most important thing. If that's the only thing you get right, you have all the names perfectly, but you know, you know, everything else about the code is horrible. That's actually probably okay. You know, 1.2, ideally it's well tested with an automated test suite. The thing that's amazing about test suites is that, you know, as you build up the code sort of from unit tests into integration tests, you're looking at each part of the code as an API, right? You're looking at your code as something that you're you know, that you have to work with, and you have to work with it at each level of the abstraction scale, right? You work with it at the smallest level, you know, the tiny little sort of unit test that you're writing, all the way up to working with it at the very top level. And so that's kind of a lot of the value of the test suite, is that it forces you to do that. And, you know, most of the refactoring that I'll do when I'm writing something comes from having to look at it as sort of a individual unit that's testable. You know, is it the least code that's needed to get the job done? You know, that's kind of important. Have you thought about, you know, how you can factor it into a simple, you know, simple limited set, or have you just pressed, you know, Control C, Control V all over the place, and really all you've done is, you know, copy the same thing in 25 different places? Does it follow existing patterns in the code base, right? This is one of those things, as you start working with more people, you know, sure, your way is fine, but if it's completely different than everything else you see in the code base, it's going to add this mental friction as people are looking at it. And that's something that, you know, as you start to think, you know, outside of just, can I make it work? That's something you should consider. You know, I would say sort of think functionally where possible. A lot of us work in object-oriented languages, but the problem with object-oriented languages is, if I have this big honking object that is 100, you know, different pieces of mutable state, it's really hard to understand what's going on at any point in time. And so, you know, thinking functionally, even in an OO language, is going to give you, you know, the ability to create these little abstractions that you can, you know, create these abstractions that let you put that sort of black box aside as you focus on something out. And it's going to make it a lot easier to sort of get into the flow as you can sort of check each item off the, you know, off the list and work on to the next, you know, the next kind of black box. You know, doesn't introduce new patterns. We've talked about that a little bit. And one of my favorite acronyms is YAGNI. You ain't gonna need it. You know, this comes from the Ruby world. But you know, one of the things that I've heard is, actually specifically Northeastern students say, is that their professors tell them to write extensible code, and that a lot of time causes me pain and suffering. I do not want you to write extensible code. I want you to write the least code possible for what you need to get done. Don't make any decisions about what we're going to do in the future. Just try, you know, there's the joke, and I'm not gonna go into the whole, thing about it, where basically the king goes to a software engineer, and he goes to an electrical engineer, and he says, I need a toaster. And the electrical engineer comes back, a week later with a toaster. The king goes to the software engineer, a week later, says, where's my toaster? And the software engineer says, well, I realize you probably don't want a toaster. What you want is just a food heating device. And right now, yes, you may want to toast something, but in the future, you may want to apply different types of heat. And so eventually the software engineer, gets put to the guillotine, right? Like, your goal should be to build the thing in front of you, right? And don't try to guess, don't try to make decisions about future projects, because you'll find a lot of those guesses, and it depends on the company as well. But I promise you at Alignable, we think we know what we're going to be building 6 months from now, but like, if I was completely honest, right, we've got a roadmap, and we'll probably throw that away, when we realize that, oh, this is the actual feature that we should build. So like, don't guess about the future, build what you actually need to build. So, level 2, we're kind of running out of time. Level 2 and level 3, the idea is that, sort of focus on, obviously as you're just getting started and you haven't written a lot of code, focus on level 0. Just obviously don't feel bad if you're just focusing on trying to getting something to work. But as you get more experience, you're more comfortable writing code or code in a specific language, start to do some of that meta thinking, right, about the code itself. Start to think, okay, this code could be simpler. This code could, have better abstractions. This code, I could, package this into 2 separate modules, each of which is self-contained. There's a lot of things you can sort of think about the code itself once you sort of get past just getting something to work. And then, level 2 is starting to think about, hey, how does this fit into the code base? How does this fit into the real world? We sort of don't expect co-ops to really get past level 1. That's kind of, the senior engineer's job is to make sure that, they kind of pull in the knowledge around level 2, how does this fit into the code base? And then you kind of get to level 3, which is you're like, okay, I've written this code. Let's say someone comes along and they have no idea what they're doing. How could they completely misuse what I've done? How could this break in the future? What time bombs am I throwing into this code? And the idea is that each of these kind of concentric circles are something that you're going to think about. But don't try to do it all at once, because again, human brains are limited and you can't stick all of it, in your head at the same time. Kind of work on each level, kind of make it automatic, and then kind of go from there. So 2 more minutes. Let me just sort of give you an example of how this works in practice. And this is from an actual, situation that happened, where we ended up with someone trying to put the level -1 anti-pattern into the code base, and there was a lot of pain and suffering, and eventually, we got to a happy place. But so let's say we wanted to add like a new 2-panel welcome screen. So the anti-pattern would be, okay, well, you want to add sort of this 2-panel welcome screen. What we really need is kind of a React panel framework that would allow us to generate panels using arbitrary JSON with these data endpoints that could. And so like you've seen that we've kind of predicted into the future how we might want to use this, when really all we asked for is like, we want a 2-panel welcome screen. So like the net result as a first pass would be 2,500 lines of code, and maybe we removed a little bit of code. So the level 0 would be, okay, they asked me to build this, I'm just going to build it. I'll build a React component, but we don't really need a whole JSON endpoint or anything. So we started cut down the amount of code we're adding, by 40%. Level 1 would be, okay, this is really something simple. Like I don't need to create a whole React, class around it. I can just create a kind of a simple line of JavaScript. Now we've wiped that 1,000 lines down to say 500 lines. Kind of level 2 is saying, well, actually, we can generalize it a little bit. We're not going to write extra code to generalize it, but really we've got a simple 2-panel class. We're going to generalize it a little bit. And turns out, I'm looking at all the stuff that's already in the code base, and I can reuse a bunch of it, and then I can wipe out a bunch of other code. And so I can wipe out all the old code, and now I'm a net negative. My favorite thing is what if a co-op leaves Alignable and they have net negative lines of code. That means that they've been doing exceedingly good work. And sort of level 3 is, okay, well, maybe we can end up just using all of our existing CSS stuff. We're just going to add this tiny little pager class in. And then, I'm actually going to take the time to write unit tests and documentation so people can understand, an entry into our visual style guides so someone can actually see how this thing works. And now, like, I've not only thought about the code I've written, how it's going to be used, I've sort of set future developers up for success. All right, that's it. I've outstayed my welcome. Thank you very much. Questions? And we do have a few members of the Alignable engineering team as well to answer any questions or to completely contradict anything that I've said. Absolutely nothing.
I was going to jump in with a comment. Hey, everybody, this is Ryan. I'm one of the engineering managers at Alignable. Pascal kind of glossed over it, but one thing, especially as you're getting going, like, don't beat yourself up as you're developing, like, just write code. And like, as he kind of alluded to, write stuff and then, maybe sleep on it, look at it the next day, rewrite it, rework it, like, it's okay to like check stuff in and then back it out and then, hey, clean it up a bit and then resubmit it, that sort of thing. So just keep that in mind as you're going along. Like, you'll look at someone's code and be like, oh my God, it's amazing. But it went through several steps before it got there. And, maybe even several years of developing. So don't beat yourself up and, just kind of look at it as a process to get to that state.
Yeah, that's a great point. Just, I would, to sort of reiterate, just write code, definitely get to that level 0, get it to work. And then, but then give it a critical eye to sort of look at it and improve it. Again, nothing. The first thing that I get working on any PR that I'm working on is usually horrible, right? I wouldn't want anyone else to have to see that. It's I end up refactoring and rewriting and definitely renaming. I'll ping other developers, especially for names, and I'll say, hey, if I told you this class name, what do you think this class would do? And if they are nowhere close to what I thought it would do, I'll completely refactor the name. Amanda or Lucy, you got anything else to add?
Yeah, I could say at Alignable, especially the code review process and like developing process is a team effort. We spend a lot of time supporting each other and answering questions and reviewing over and over. It's very iterative and very collaborative, which is really fun. Especially, as you like go through the code review process, we encourage our new engineers to review code as well, because you learn from the senior engineers how they put things together just as much as you learn from their comments on your code as you're going through things, which is kind of fun.
Yeah, just to add on to that, I think another important thing is that sometimes working with people can actually help you get to a higher level. So you shouldn't necessarily feel bad that, maybe you weren't thinking about things and then you talked to someone and then you started thinking about more higher level ideas, because like, it doesn't matter if you needed help to get there. The point is like that you got there, and it's sort of supposed to be collaborative. Like people are sort of supposed to help you get to that higher level. That means you're both doing what you're supposed to do, because we all sort of work better when we are working together. So yeah, it's not just like you write it and then you try to make it really good all by yourself and you try to make it perfect and then you give it to other people to review. It's more like you have something and that other people will help you make it better.
Yeah, and I would say, while you're in school, team projects get a bad rap, but they're, I would say collaborative team coding projects can actually be hugely valuable. Obviously pick your teammates if you can, but do treat those as kind of collaborative exercises. Get that GitHub repo up early, and tell people to commit early and often, and make it a collaborative experience as opposed to just yelling at the one person who didn't commit any code 2 days before the whole thing is due.
So if I were to summarize, your advice to like students who are developing their coding skills would be to code often, get feedback, read your code, and aspire to the ideals you laid out for us.
Yeah, I would say step one is most important is do code, right? Some people I've seen have really nicely curated GitHub profiles, and I think that's terrible. Like if you have this, like you've got 3 sort of perfectly documented and perfectly working repositories on GitHub, and that's the only thing that you have, that isn't what I want to see. I would love to see 50 half-built repos of all the different things that you're trying, all the things that you're trying to do. Like that kind of tells me that you're looking at this kind of as a craft and a skill that you're working on, and just not some horrible thing that you have to do in college, right? So yeah, I think it's like code early, code often, and look at your, like, code early, code often, and actually look at your code would be how to summarize this down into the into 3 lines.
All right, well, if there aren't any more questions, oh my gosh, Emma. Well, thanks so much for coming. I really enjoyed that presentation. Sometimes it's just really good to refresh and also be reminded of the things you want to look for in your code, and also to actually do the coding instead of just talking about it. So yeah, I hope you guys enjoyed our meeting, and you guys are free to go, and unless you want to stay on for more questions or anything like that. But yeah, have a good evening and a good week.